Welcome back to ninth session on unit number 6, dimensional analysis and similitude. This session we are going to discuss the fourth model law, that is Weber model law. In a fluid system where surface tension effects predominant in addition to the inertia force, the dynamic similarity is obtained by equating Weber number for the model and its prototype, which is known as a Weber model law. So Weber model law is generally applicable where the surface tension effects are taken into account. So according to this law, Weber number of model is equal to Weber number of prototype. This is the expression of Weber number, that is V upon under root sigma rho into L, where M suffix is used for the model. So V is the velocity, sigma is the surface tension, rho is the density, and L is the length. And M suffix is used for model, V suffix is used for the model. Weber law is applied in the following flow situations: the flow over weirs involving very low heads, then very thin sheet of liquid flowing over a surface, then capillary waves in channel, and capillary rise in narrow passages, and capillary movement of water in a soil. So where whether the effect of surface tension is considered, especially the capillary waves in the channels take place where that capillary waves is because of the surface tension. Normal channel, the Froude law is used. So for most of the cases, the Froude law and the Weber law, they go hand in hand. In some analysis, both are required. We take numerical on the same. The prototype spillway has a characteristic length of 3 meter per second and a characteristic velocity of 3 meter per second, and a characteristic length of 10 meter. A small model is constructed by using Froude scaling. What is the minimum scale ratio of the model, which will ensure that its minimum Weber number is 100, and both flows use water at 20 degrees Celsius. So this is the example. In this example, the prototype values are given. So for example, velocity of spillway in the prototype is 3 meter per second. The characteristic length is given. A small model is constructed using a Froude scaling, but that model also ensures that the Weber number is minimum 100. So we have to use both models to get this scale ratio. Scale ratio means the Lm by Lp or Lp by Lm. Both are same. Now Lp is given, we have to calculate Lm. Now as far as the Weber law is concerned, so Weber number is given by V upon under root sigma sigma into L. So this Weber law we can first apply, but actual construction of model, it is by using a Froude scaling. So the length we obtain by using Froude scaling because these values. So according to Weber law, first of all, we'll apply because Weber number is given and that is for model. So we use the relation of Weber number for model, that is Vm upon under root sigma upon rho L for model, that is equal to 100. Now, as both flows use water at 100 degree, sorry, at 20 degrees Celsius. So at 20 degrees Celsius, the value of surface tension is 0.0728 Newton per meter. These are the standard values. Even it is not given in the data, you must know the values of standard fluid. That is sigma is 0.0728 Newton per meter, and density, that is 1000 kg per meter cube. So is kg per meter cube. So by putting these values, we can develop again in this equation Vm and Lm are unknown. So the above equation becomes Vm in terms of Lm. Now, according to the Froude law is V upon under root Lg. In this case, G is because both are at the ground level, so G is common, so get cancelled. So Vm upon under root Lm, that is equal to Vp upon under root. Now in this case, the right hand side known to us, that is velocity of spillway, Vp and Lp, both values known to us. So we can calculate the Lm value. So because Vm we can substitute in terms of Lm. So if we substitute this in this equation, we can calculate Vm. So we can calculate Lm because only unknown in that equation, then it becomes only Lm. So Lm comes around 0.899 meter, or Lm by Lp, that ratio, that is the scale ratio, that is 0.09. So this way we can solve the problem. So most of the cases, the Weber number and Froude number, they are, because in both cases that they are naturally occurring flows, even a capillary action, that is flow due to surface tension and due to gravity. In both cases, the natural occurrence is there. So that's why generally both numbers required, or both laws required while solving the problem, if it is related with the surface tension. That's it. So minimum scale ratio is 0.09. That's it from this session. So at the end of this session, you will be able to explain what is Weber model law with its application. Generally, it is applied where the surface tension or capillary actions takes place. And also, you will be able to apply this Weber model law to solve the problems. I think this type of problems are very rare. Generally, it is not in engineering background. Most of the advanced physics, this particular and problems or situation arises. So in that situation at the micro level, this particular model is used, not in engineering background. Engineering background, mainly it is required in two-phase flow only. With this, we end this particular session. Thank you very much.